Hi, welcome back to Firebase Gaming. This is Johan, and today I want to share about a very powerful pattern, but that's relatively easy to implement and it will improve your software project significantly. These are called remote configurations. If you've ever wondered how big apps like Grab or Uber are changing the theme from normal to Chinese New Year or Christmas based on the time of the year, or how big companies like Google are launching mobile app features at the same time all over the world, or how shopping companies like Lazada, Shopee, Amazon are testing different shopping cart experiences on their mobile app with different users, or even how mobile games are dynamically adjusting prices of virtual items in the store. All of those examples are relying on some kind of implementation of a remote configuration. So how does this work and how can you implement this pattern in your project? Let's look at it today. So you have an app typically with some magic number. Let's say the number of pictures you want to show on the home screen, let's say 5. So you have this magic number over here, and remote configuration simply means you take this value, move it from the client on the app to a server somewhere in some database. So now you have a copy of that value on both the app and the server. What you want is you want to establish the server as the new source of truth for that value, meaning that the server knows the latest real value and everybody else connecting to the server will have some kind of cached copy of it. Okay, they only had a copy of it. You have some kind of API that you need to build, like a REST API or something that will allow all the clients, so all the apps, to connect to the server and get the value. Typically, you would give a name or an ID to that value, let's say number of pictures on the server side, and then in your API, you say, hey, give me the value for number of pictures. So this basic setup here where you have an app, a server, and a contract allowing the app to connect to the server and get the latest value. This is not exactly all you need, but that's the basic fundamentals of what you need. Now, there are a lot of consideration that you have to have. First, you want to be able to change that value on the server, so you should create some kind of dashboard or any kind of web service that allows you to dynamically adjust that value. You will also want to add some maybe history tracking of the various changes of that value, right? And maybe some even auditing or logs so that you know who changed those things. So if Bob decides to change the price of the MacBook Pro from $3,000 to $150 overnight so that they can make a purchase for cheap and then change it back to $3,000, you want to be able to track those changes and know that Bob did it. Okay. Also, you want to be careful about not storing heavy server-side values. Imagine a huge image for the entire wallpaper of your app. You don't want to serve that image unnecessarily to all the clients if they already have it. So instead of in your API, instead of sending the image down, you might send a URL of the image down, and then the client can see, oh, I already have that URL, so I don't need to download it again. Of course, caching will come into play here, but that's a basic idea. But serving heavy server-side values is actually quite common. That's how you do DLCs for games, for instance. You would say, okay, this is DLC ID 1, 2, 3, and the app can choose, okay, I need 1, or I need 2, or I need 3, and then they can download it from the server. But the server will expose the list of DLCs that are available to the app. So you also want to think, okay, now my app has a copy of that value. Okay, so you need to think, okay, how do I synchronize the copy of my value from the app between the app and the server? So of course, the naive way of approaching this would be, well, the app, every time it launches, it checks with the server what's the value for the number of pictures I should show on the home screen. So the app launches, connects to the server, gets number 5 down, and then the app shows 5 pictures on the home screen. And immediately, it should tickle you and think like, oh man, if I do this, my app startup will be really slow. And you would be absolutely right. So obviously, you don't want to do this as a gatekeeper before your app starts. So you want a cached copy that works offline. So if your app is not connected to the internet and then you're waiting for the server to give you a config, yeah, you're going to have problems when the user is in the metro or subway and then can't connect to the internet, and they won't be able to use your app and they will hate you for it. So you have a cache copy of that value on the client side, and then you say, okay, now I can create a job that will periodically sync between the app and the server value. So how frequently do you want to sync? Well, it depends on the value, right? If you have something that changes very infrequently, maybe once a day or even once a week might be enough. Maybe once a day you check, okay, do I have new values for all of these less important or less critical values or less critical keys for each of these values. And then you sync up when the app is running or in the background. And so what you sync up is you store the new values into the local cache of the app. So next time the app starts, it will use the values from the cache. And that last step is very important because think about it. I talked about numbers and strings, but what if you use Booleans, right, to to enable features of your app? So a Boolean would be, is the feature enabled true or is the feature enabled false? If it's true, then maybe my app will change to show new buttons or new screens in the app. And if you don't update the cache of the app and instead update the in-memory version value of this app, what will happen is the app will start with the feature turned off. And then the user goes into various screens, starts navigating, and then someone changes the value on the server, it syncs up, and then you realize, and then suddenly your app has the feature turned on. And that's very weird because you might end up in an inconsistent state where certain screens or certain behavior of your app depends on that feature being turned on or turned off right from the beginning. So you want to avoid doing that and always sync up with a local cache or local cached value of that remote value rather than change the in-memory value. There is maybe one caveat to that is, or exception to that I can think of, is what we call a kill switch. So it's very frequent when you have an app running in the wild that at some point you realize that you have a critical bug that you really want to fix, or there's a security vulnerability, for instance. And you want to be able to quickly kill the older versions of your app, the ones where the fix is not patched in yet. So let's say your app version is 5 now, and then you discover that version 3 and below, they have a security vulnerability. So you want to kill all of those apps that are not at 4 or 5 right now. So what you would do is one of those values on your server might be some kind of minimum compatible version or minimum version for your app. And you say, okay, the minimum version is 4 because anything before 4, they have the security vulnerability. So when the app syncs up, maybe this one is a critical one, so maybe you check every hour or something. When the app syncs up, it can store, of course, the minimum value in the local cache, saying it's 4. Next time the app starts, it says, oh, I'm version 3, I'm below the minimum value, and I show an upgrade prompt to the user, and I prevent the user from upgrading the app. You could do it in a softer way where you allow them to use the app, but then you have this annoying notification that's always there, upgrade it, upgrade it, upgrade it. It depends on how severely you want to fix that bug. But if it's a really severe bug and you want like that kill switch to work immediately, then you could update the in-memory value of the app, and then the app would check against that in-memory value rather while it's running. And this can be important because very often you realize that a lot of users don't close their apps. If you look at, I know when I look at my parents, for instance, they have 15 different apps running in the background. They don't close them. They wait for the system to kill them when they need more memory, right? Or when they reboot the phone. But rebooting the phone is also a very rare occurrence these days. And so sometimes some of these values need to exist in memory and need to be able to be checked against in memory. And maybe this would force the app to restart. And then when the app restarts, it just triggers the kill switch. So how can you use this? A few different ways. The basic one is, as I mentioned, feature launches. So you can use a Boolean that indicates whether the feature is turned on or off. What you do is when you are developing the app, you turn on the feature in your development build. And then so you can happily see what the app looks like with the feature. You can also write tests where the feature is on versus off. So that's very easy. You turn on the flag locally and then compare, run the test and see how the app behaves when it's on versus off. And then in your production build, you turn it off by default, and then you let the server control the truth value of that flag. And what you say is, when I'm ready to launch, so when enough people have downloaded the new version of the app that contains the feature that I want to launch, I can simply slowly turn on that feature. I could immediately turn it on, and so everybody connected to the server would get the feature, or I could wait and then do a gradual ramp up of that value where I say, okay, maybe 10% of my user base will get the new feature, and then I can observe like how well the feature is behaving. Am I getting a lot of crashes or high error rates on that feature? Then I'm happy with 10%, I ramp up to 20. I'm happy with 20, wait 3 days, 4 days, whatever. ramp up to 50%, and then eventually ramped up to 100%. So that allows you to control gradual ramp up of your feature and then make sure that it doesn't crash too often, or it doesn't cause more instabilities. And then you can roll it back too, ramp it back down, right? That's the beauty of configuration. You can launch a new feature, ramp it up, realize that actually it does more harm than good, then you roll it back down. So that's one perfect example of how to use remote configuration. Another one I mentioned earlier is changing the theme of your app, or even the behavior of your app based on these configurations. So what you would do is all of these assets that your app is using, the UI elements, the images, even the text, and even the layouts, depending on which language you're using on the client side, you can bundle this all together into big zip files. And then you upload these zip files to the server, and then you can create copies of these. And each of these zip files can represent a different theme. So you can say, I have a copy, I change all of the assets to be red now because it's Chinese New Year, it has to be red. Or green, if you want to, or Hari Raya and things like this. So you change the assets, and then you create a new bundle, and then you give a URL or unique ID for each of these themes. And on the app side, you can download the themes that you will need in the future. So maybe the server tells you, okay, you will need that theme by that date. And then after that date, when the app starts, it just unpacks, and then instead of loading the regular assets, it will load the themed asset. So that's one great way of using remote values, where you can store themed information and then bundle up all of your assets and put them on the server. DLCs work that way too, right? Where they can say, I can swap the theme of my game, or I can add an extra level, or all of these things, and the server will serve you those as needed. Or you can unlock, unlockable. So maybe you don't bake in everything into the app yet, and when the user unlocks it, so first you download what's unlockable, and then the user can download it later. Now you can also use remote configuration to change the behavior of the app itself. So I mentioned how shopping cart experience flows, user flows can be very complicated. You have to select the item, put it in the shopping cart, enter your address, enter your payment information, check out, do the payment, and then there's the post-payment, information screens, and maybe sometimes there's even additional information that needs to be completed. These are very complicated. They create a lot of friction, and a lot of users drop off. So you want to be flexible about how you construct these user flows in a modular fashion, so that you can dynamically test what is the best way to reduce the friction and help user go through the flow as easily as possible and eventually complete their purchase. So it's a very common way of doing it. You can create modules representing each individual steps of your flow. Maybe I do A, and then I do B, and then I do C, right? So basic flow, enter your add to cart, enter the address, and then checkout. And then at the end, you have the post checkout screen that says, thanks for buying, blah, blah, blah. Here's an email, a newsletter, and all of this stuff. And each of these A, B, C, D steps can be moved, can have an identifier on the server side, and you can decide in which order you do those. Or you can also decide about how do you configure A, B, C, and D. Maybe you have a bunch of text that you need to display, or maybe you have images to illustrate what you're buying and stuff like this. So on the server, you can specify what values, how do you configure each of these modules? Do I want to remove one step because it's unnecessary? Maybe I remove D and then make it less friction. Or maybe I swap B and D, or maybe I add another one, F, for certain types of users, right? This is what we call A/B testing, where you would be using remotely configurable values and then run different versions of your flows against different users and see which one performs the best. Okay, so you can also use what we call diversion criteria. So how do you decide between going between B and C and going between B and C through F? You can say, okay, 35-year-old Singaporean males will use F, but non-35-year-old or non-males will use B and C directly. So that allows you to leverage some of that user data that they're consenting on giving, and say, okay, maybe I can try to see which flows work best against which kind of population. So that's called the diversion criteria. That's also very powerful, used very frequently. And it allows you to really fine-tune the experience of your app. And if your app is built in a very modular fashion, you should be able to also dynamically inject new steps like F here, for instance, with a web view, or for having configurable modules where you can choose, how many buttons you put and where these buttons go when you click on them. So if you can build your app in such a fashion, you have an extremely modular app, and you have the capability and the flexibility to change the behavior of the entire app controlled by the server. So, all right, this is the end of the quick tour of the wonders of a remote configuration. It's a really powerful concept, often underutilized, but it's so flexible, and it provides you with very various things you can do with it. If you remember at least one thing is the kill switch, make sure you always launch your apps with a kill switch, because there is a very long tail of users that do not update their apps. And so you don't want your version 1 to be stuck out there for many years when you're already at version 25. And so make sure you have a kill switch with a minimum version required for using the app, because that will allow you to upgrade your servers, so that you can change the API contract between the app and the server. If an app is stuck in the past, they are stuck in the old contract, so you will never be able to change it unless you force these apps to upgrade to a new version so that you can change the contract. Right? Hope it's interesting, and as usual, don't hesitate to reach out if you have more questions, and I see you in the next one.